All right, we're going to follow up with definite integrals, but I do see here in number 1 that there is no a and b value, so this is called an indefinite integral. And we're not going to actually get a single number, a value here. We're going to get another function. So if we integrate the first function, the negative 2 you can just kind of leave on the outside and just concentrate on the integral of x cubed. So we know its derivative is 3x squared, so we're really trying to think of its antiderivative. So you're adding 1 to the power, and you're multiplying by 1 over that power. So this way, when you take its derivative, the 4 and the 1/4 would cross out, and you'd be down to a power of 3, just like the original. In the second function, you had just a 4. The integral of 4 would be 4x, because the derivative of 4x is 4. In the third one, you're leaving the 2 in front and just doing the integral of x to the negative 3 dx. And so when you add 1, that's a negative 2, and then multiply by negative 1 over 2, or divide by negative 2. It's really up to you whether you're going to write fractions in front or divide. And because it's an indefinite integral, you have to remember that there could have been some number here because its derivative would have been 0. So even on Delta Math, if you don't put plus c, you will not get the full credit. And then it's just a matter of cleaning it up. Whether you write negative 1/2 x squared or x squared over 2 with a negative in front, it doesn't really matter, I don't think. And then here, it looks like you're left with 1 over x squared. So in number 2, you are finding a definite integral. So this one actually has a number value to it. It's not like this problem was very difficult. I just really more wanted to talk about the problem in general. If it had said 5 to 1, you would just be plugging in numbers in the opposite order. So when it says 1 to 5, you are doing the antiderivative of negative 3, and you're putting a 1 at the bottom and a 5 on top. So you actually plug in the top number, then you plug in the bottom number, and you subtract. And so that should lead us to an answer. If it had said 5 to 1 instead of 1 to 5, then you would have just switched these numbers anyway, and you would have switched the order of these. So the answer would have been the opposite, because we know the integral from a to b is the opposite of the integral from b to a. But if you're using this fundamental theorem of calculus here, you don't have to worry about the negative. It'll take care of itself. We could check this answer because it's such an easy function to graph. This function is negative 3 from 1 to 5. You can see the area is under the x-axis. It's a 4 by 3. So the area is 12, but the answer to the integration is negative 12 because the area was under the x-axis. So again, if you're using the fundamental theorem of calculus, you don't really need to worry about negating anything. The answer automatically comes up what it should be. In this problem, I just wanted to double check that you remember the average value formula, okay? This question actually asked the average value from, I believe, negative 2 to 8. So if you look at from negative 2 to 8, 2 of the values are under the x-axis. So in the problem, it said the area of B was 3, but you'll notice down here they write it as a negative 3, and they said the area of D was 10, but they put it as a negative 10. And of course, C must have had an area of 16. So there you do have to put the negative in because they were telling it to you as an area statement, not as an integration statement. And then we have our nice review problem, the equation of a tangent line. So what's nice to remember is what we have is f of x. And if we want an equation of a tangent line, we're going to need a point and a slope. So as we start to find the derivative, it's going to be confusing because I'm now going to make you start doing antiderivatives. So do not forget how to find a derivative and then practicing integration, how to do antiderivatives. Now here, if we want the point, we're going to plug 2 in the original. So by plugging 2 into the original, it looks like we get negative 8. And if we plug 2 into the derivative, what do we get? Negative 20. And then we have to remember that a tangent line approximation, right, is f of a plus the derivative at a times x minus a, because we are just working off a point slope form there. So the equation line at 2, right? So it does say at x equals 2. So the function at 2 could be represented by whatever f of 2 is, what is the slope at 2, and then actually at the number 2. So it's just a matter of if you want to clean that up or not. So this should be helping us with our newest Delta Math assignment.